Hey guys, welcome to Learn Today IGCSE. This is a tutorial video for Physics, Paper 6, Variant 6-2 for May June 2023 examination. Question 1. A student investigates the stretching of a spring. Figure 1.1 shows the setup. Okay, I would suggest you guys to just take a minute to understand the setup of the experiment before proceeding to read the rest of the question. You have a clamp stand holding the spring and a meter ruler to show you the extension of the spring, all placed on a bench. Question A. The value L0 is the length of the spring when the load L is 0 newtons. The student measures the length L0 of the spring. She records L0 equals to 16 millimeters in table 1.1. Draw a diagram of the spring to show clearly the length of L0 of the spring. Firstly, let's draw out the spring from the diagram. You are required to show clearly the length of the spring without any load. This means that you should measure by taking the top to the base without including the hook of the spring. This is the only part of the spring that will extend when the load is added, therefore we can label this as L0. Question B. The student suspends a load L equals to 0.2 newtons from the spring. She records the new length L of the spring in table 1.1. She repeats the procedure using L equals to 0.4 newton, 0.6, 0.8 and 1 newton. The readings are shown in table 1.1. Question 1. Calculate the extension E of the spring for each load using the equation E equals to L minus L0 and record the values of E in table 1.1. And part 2 of the question, complete the column headings in table 1.1. To get the value of E, we can use the formula L minus L0. The value of L is already given in this column of the table, and we know that L0 is 16 millimeters. We can now proceed to complete the column headings. Question C. Plot a graph of L y-axis against E x-axis. Draw the best fit line. Okay, first let's draw the x and y axis. Your x-axis is the extension of E in millimeters, and your y-axis is the load in newtons. Always don't forget to include your units when you label your axis. Looking at this table, the range of x-axis is from 0 to 10, and for y-axis, it's from 0 newtons to 1 newton. For our scale on x-axis, we have 6 big boxes, so we can just set one big box as 2 millimeters. And for y-axis, we also have 6 big boxes, so we can just set one big box as 0.2 newtons. After completing the x and y axis, we can plot all the points from the table now. And some of you were asking whether you should draw a straight line or a curve. Well, it should be obvious once you have plotted your points. For this graph, as you can see, we will all observe a straight line. So for a best fit line, just try to connect as many points as you can and extend your line until the end of the graph. It doesn't matter if you have some points which is out of the line or out of the range of the graph, because a best fit line means that you have a continuous straight line and not a graph that looks like this. This is not a best fit line. Let's look at another example of a different set of data which does not start from origin, and if you were asked to draw a best fit line, don't try to force your line trying to go through from the origin. Because as you can see here, you're only connecting 2 points and there are many points which is out of the range of the graph. Instead, try to look for a line that connects the most number of points even though it does not start from your origin. And this is another example of a best fit line. If you have any more questions regarding a best fit line, just please ask me in the comment sections below. Moving on. Question D. Use the graph to determine EA, the extension produced by a load of 0.5 newtons. Show clearly on the graph how you obtain the necessary information. So at load y equals to 0.5, draw a straight line until it touches the graph and identify where it connects at the x-axis. For me, it connects at the point of 5 millimeters. According to your marking scheme, any values from 5 to 5.4 millimeters is acceptable. Question 2. A student investigates the cooling of water. Figure 2.1 shows the setup. Again, always take a minute to understand your setup before moving on to answer your question. Here you have a beaker, a thermometer to measure temperature, lid most probably which goes to cover the beaker, and a bench that holds all your apparatus. Question A. The thermometer in figure 2.2 shows the room temperature theta R at the beginning of the experiment. Record theta R. Temperature from the thermometer is 23 and do not forget your unit degrees Celsius. Question B. The student pours 200 cm³ of hot water into a beaker. He places a lid on the beaker. He places the thermometer in the hot water in the beaker. This is what the setup looks like. He records in table 2.1 the temperature theta of the hot water at time equals to 0. He immediately starts a stopwatch. He continues recording the temperature in table 2.1 at 30-second intervals until he has 7 sets of reading. Part 1. Complete the column headings, and Part 2. Write the times in the first column of table 2.1. To complete the headings, insert your units. For time is in seconds and for temperature is in degrees Celsius. It mentions that it starts at time equals to 0 and continues every 30-second intervals. Question C. Part 1. Calculate the decrease in temperature theta between time 0 and time 180 seconds. And the value for the change of temperature theta would be 17. Part 2. Calculate the average rate of cooling R of the water using the equation R equals to change of theta over change of time, where change of time is 180 seconds, include the unit. So for change of time equals to 180 seconds, you are going to take this whole range, meaning that for your change of temperature, it will be from 92 to 75, which is 17. The value of R that you would get would be 0.0944 and so on. So you can leave your answer as 3 significant figures, which would be 0.0944. And the unit is degrees Celsius per second. Do not forget your units. Question D. A student states that the water cools slowly. Suggest 2 changes to the experiment that the student makes to increase the rate of cooling of the hot water without changing the starting temperature of the hot water. Room temperature remains constant. We can do this by using a thinner lid so that there will be more heat loss towards the surrounding and the temperature will drop faster. Or we could also remove the lid from the beaker. Any logical answer that will cause the heat loss to occur at a faster rate is an acceptable answer. Question E. State one precaution that you would take to obtain accurate temperature readings. Explain briefly the reason for this precaution. One of the most common precautions that you should take while obtaining an accurate reading is to place your eye perpendicular to the scale. This is to avoid parallax error. Or you could also mention any of these precautions. Question F. The student uses a measuring cylinder to measure 200 cm³ of water. He takes the reading from the bottom of the meniscus. Explain the reason for taking the reading at the bottom of the meniscus rather than at the top of the meniscus. This is because there is a very small volume amount of water between the bottom of the meniscus and the top of the meniscus. Question 3. A student investigates the refraction of light using a semicircular transparent block. Figure 3.1 shows a ray trace sheet. Let's understand this setup before answering the question. This is an experiment to observe the ray of light, and we use pins to trace the ray like this. In a ray trace experiment, we will place a ray source from one side and observe the emergent ray from the other side. So let's say if we place a ray box over here, there will be a light source in this direction. And when it passes through from glass to air, the ray of light will bend away from the normal into the observer's eye. That's why you can see two pins here to show you the ray of light. Okay, let's get started. Question A, Part 1, consists of 4 bullet points and we will answer it one by one. The first bullet point is to draw a normal NL through the center of AB. Using a ruler, find the center point of AB and draw a line perpendicular to the boundary of AB. And this will be your normal NL. Bullet point 2, continue the normal so that it passes through the curved side of the block. This is the curved side of the block and we have already drawn our normal passing through it. Next, point 3, label the normal NL. You can label it at the top or at the bottom, it doesn't matter. And for your last bullet point, label the point C where the normal NL crosses AB. So the normal NL crosses AB at this point